Okay, in Chapter 9 of Algebra 1, it deals with primarily with graphing quadratic equations. And again, quadratic equations take the form y is equal to ax squared plus bx plus c, where a, b, and x represent coefficients, which means they represent numbers. And when you graph them, they always take a shape of parabola. And a parabola is kind of a cross between a v and a u. It's a very specific kind of shape that you'll learn more about in Algebra 2, but for now, this is the basic shape, is this black curve right here. And it's got certain key parts of it. There's a vertex where it turns around. It's the bottom or the top point, because a parabola can curve downward, as we'll see later. And it's also got an axis of symmetry because it's symmetric on both sides. It's a mirror image, and so there's an axis of symmetry. And it'll ask us for all these sorts of information about the parabola, and we also need to know how to graph it. So we're going to go through all that. So we'll start with the axis of symmetry. We're going to do everything with this one problem. Now, the equation for the axis of symmetry is x is equal to negative b over 2a. And that is the whole answer. It's not just whatever you get in the formula. It's x equals whatever you get. We'll see that here in a second. So if I look here, the first thing I'm going to do is identify a, b, and c. So a is the coefficient in front of the x squared, and so that's negative 2, which would make b the coefficient in front of x, or 12, and then c is the number all by itself. Okay, so if I plug those numbers into here, I get x is equal to negative b, negative 12, over 2 times a is negative 2, is negative 12 over negative 4, which is 3. Okay. And so my answer for the axis of symmetry is x is equal to 3. Not 3, because 3 is a number. We need a line, and so we need an equation. So the axis of symmetry is x equals 3. That is the answer there. Okay, now if we're to find the vertex, we've already gotten halfway there because the vertex goes, the axis of symmetry goes through the vertex. And so the vertex is calculated where the x coordinate is what we just found, negative b over 2a. And once we have that, we plug in to find y. So we plug this in over here to find y. So I already know that this is 3. We already figured it out. We're going to plug that in to find y. So I'm going to plug in 3, and I will get y is equal to negative 2, 3 squared plus 12 times 3 minus 5. So if I do that math here, that's 3 squared is 9, times 2 is negative 18, 12 times 3 is 36, minus 5 is equal to, so negative 18, or say 13. Okay, so that's the y-coordinate. So the x-coordinate is 3, we already found that. The y-coordinate is 13. So right here I'm going to go 3, 13. All right. Now, the next question, max or min? It's asking, it's asking two things. Is it a maximum or minimum? Does it have a bottom or a top? And what is that value? And so the first thing that we identify is you have a maximum. Let's see here. Maximum happens when a is less than 0, and a minimum happens when a is greater than 0. Another way of saying that is when a is negative or positive. Okay. So here a was negative, it's negative 2, so I have a maximum. So I know that much, and the max or min is always the y-coordinate. This is the max or minimum value, the y-coordinate of your vertex, because that's the top or bottom depending on the graph. In this case, what this is telling me because this is negative, I have a maximum, I have a top, and that top is at 13. And so I have a max of 13. Okay? All right, now we're going to find the domain and range. And we're doing all this even without looking at the graph. It'll become more clear when we see the graph, but we can do all this without the graph. So now for the domain and range. Now, the domain is actually relatively easy, well, really easy in Algebra 1 because the quadratics you'll be getting, you can plug in any number for x. There's no number you can't put in. And so the domain will always be, in these cases, all real numbers. So you can write out the words all real numbers, or you can use a symbol that represents real numbers, which is a capital R with a double line on one side. So that would say all real numbers, the set of all real numbers. Okay? And then what we said is that the up and down has a top, a maximum of 13. So that would mean that the range is where y is, make that smaller, y is less than or equal to 13. Because again, the top, the max is 13, so y can't go above it. So the range is when y is less than or equal to 13. That'll become even more clear when we graph here. And so we're going to use all this information actually to help us graph. And to graph, the easiest and best way is to make one of your t-charts, x and y. And in a parabola, you need at least 3 points to graph. And it's generally helpful to have 5 so you get an accurate graph. And if you've got none of this information, sometimes you can start at 0 and go for there. But if you figure out the vertex first, then you already have one part of your t-chart, and that's the best part to put in the middle. And I'll show you what that means in a second. Because it's kind of in the middle of the graph, so if it's in the middle of your t-chart, then it will help you get the most accurate graph. So 3, 13 is the vertex, so I'm going to put 2, 4, 1, 5. So I'm taking from the middle and I'm expanding there. And then I'm going to plug these numbers in. Plug these numbers in, 4x into there, and that'll tell me what y is. Now, I'm going to keep going, but I would ask you to pause right now and plug in the numbers yourself just to check to make sure that the work that I do is right and that you're following along correctly, okay? All right, so go ahead and pause. I'm going to be working on this, and when you come back, it'll be complete. Okay, so these were the values that I got, and what you'll notice is that if you find the vertex, and then if you go 1 each direction, every time those numbers are going to be the same when you plug them in and solve for y. And that's because of the symmetry of the shape. So 3 is a vertex, so if I plug in 4 and 2, which are 1 away, I will always get the same number. And 1 and 5, which are 2 away from the vertex, I'll get the same number. And that's a way to also verify that the original calculation you did was correct, because you got the same number twice. Now, what we're going to do simply is graph these points to graph the parabola here. And so I'm going to go to 3, 13. 3, 13 is about right there. And then graph all these other points. So we've got 2, 11. 2, 11, 1, 5, 1, 5, and then we've got 4, 11, and 5, 5, there-ish. Okay. And as you can see here, I have got points that would, if I connected them all, I would require a curve to keep it smooth. You can't connect them in straight lines, or else there comes sharp points. And so the way to do this, best way to draw a parabola, is to kind of think of the top of a parabola as going horizontal, or top or bottom. And so think that you're going horizontally here, and then you're starting to curve really quickly towards these points. So that you see my top is horizontal, and then I'm curving. And then that curve just slows down, so it gets straighter as I go out. or at least visually straight, or mathematically it's actually the same curve, but you won't learn that for a long time. And so there you go, there's my parabola. Again, I just plotted the points and then drew my best curved parabola style shape through them. And that's how you do it. That's how you find the axis of symmetry. Here's the formula. You plug in that number that you get for the axis of symmetry to find the y-coordinate of the vertex, and those two together make the vertex coordinate point. The y-coordinate point of the vertex is your max or min, and how you tell which one it is whether A is negative or positive. And then the domain for these ones in this unit are all real numbers, and the range is dependent on whether it's a max or minimum. If it's a max, it's less than or equal to, because it's got to be under the max. If it's a min, it's greater than or equal to whatever that y is in the vertex. And then to graph, you start with the vertex and expand the points from there. And so there you go. That's pretty much 80% of Chapter 9.